For this video, I'm going to start with today's Do Now, and the Do Now is out of the Zoomdal textbook, and if you look at today's date, which is the 25th, you will see a link for that page that shows you what these problems are all about. So we'll just continue. Philip was giving us the stress as pressure. I did it as oxygen when I wrote it the first time. Both will work exactly the same way. So we're going on now to figure out what in the world is Zoomdal going to be able to do with the given equation to be able to bring the oxygen down. Now, Philip, do you understand that we get rid of something by combining or by taking apart? In this case, it's all combining because both sides of the equation have two substances. Okay? So, which side has the oxygen on it? Yes, the O2. Okay? So, we're trying to reduce the amount of oxygen, and it just so happens that we can reduce the amount of oxygen by putting ammonia and oxygen together. On that side, we have a total of 9 moles, 5 for the oxygen and 4 for the ammonia. On the other side, we have a total of 10 moles. Okay, but we're trying to get rid of oxygen. So as we get rid of oxygen, what are we going to do? What do we combine? Oxygen and ammonia. You bet. And oxygen and ammonia give us a right shift when we put them together, because that's the way the reaction goes to use up those as reactants. If we were putting nitrogen monoxide and water together, then that would be the reverse reaction. And so those two guys would be getting put together, and the two guys that we're combining over here would be being produced. Does that make sense? Okay, it's important to understand what a chemical equation actually means. That you're actually getting rid of your reactants, whether it's forward or reverse, okay? You're getting rid of your reactants and producing products. Okay, so let's move on. And Senik, what do you have for the stress on 33B? Okay, and ammonia up? Oh, you mean H2O is up? Neither one. In 33B, a desiccant is a material that absorbs water. So when it absorbs water, it reduces the amount of water in the vessel. Okay? So if I'm reducing the amount of water in the vessel, we know what's going to happen next, right? Okay, no problem. Now, what do we have to combine to get more water? I'm sorry? NO? That's going to use water up. NO and H2O combined, there is no more of either one of those. They're gone. They're being used up. They're being regrouped into ammonia and oxygen. What we're trying to do is get rid of the water. I'm sorry, we're trying to make more water. So yes, the NH3 and the O2 are going to be combined, and by combining those, we'll make nitrogen monoxide in the water. So that's what you're going to see here, ammonia and oxygen. And so if we combine these guys, which way will we shift? Correct. Okay, so it's going to be the same shift for different reasons. Okay? For totally different reasons. All right, going down to the last one. The system is compressed and ammonia liquefies. So we got two things going on. Ammonia is liquefying, which means it's no longer going to be, what is it, a reactant or a product? Ammonia is a reactant. Okay, so the ammonia is going down, and as the ammonia goes down, the pressure is going to go up, right? Yeah, okay. So, let's get someone else in the act here. Yeah, she's not here. And let's go on to someone else not here. A lot of people out today. Susanna, you get to do this one. You know what the next one's going to be, don't you? Yeah, okay. Pressure down. And how are we going to get pressure down? We're going to what? Reduce the number of moles. Okay, which side is going to give us fewer moles? Reduce the moles, and which side has fewer moles? The left or the right? The left side. Okay, 4 plus 5 is 9. On the right side, we have a total of 10. So we're going to combine nitrogen monoxide and water, and we will do a left shift. So as we combine or take apart, you're seeing now, I hope, a little better idea of what is actually going on. There's 3 problems here that I haven't done on a video, so I'm going to do those right now. And that is 13A. 13A is out of our textbook, and it's on page 574. So I'm looking at 13 with the reaction of ethene and water producing CH3CHO. And I don't remember the name of that guy, but it's an organic acid. So, at any rate, first thing that I see here is an increase in the amount of our product. And there's actually 2 products, CH3CHO, and this is exothermic, so heat is also a product, but we won't have to be concerned with that because heat's not changing, or temperature's not changing. So we always deal with temperature in terms of heat. So the CH3CHO is increasing according to letter A, and because LeChat always wants to do the opposite, we're seeing CH3CHO is going down. And I hope those of you in the class right now are using this opportunity to get these down as practice problems for you to get a better idea of what's happening here. So because CH3CHO is on the right side, I have to break that dude up. So I'm going to break that stuff up, or rather LeChat will, and by doing that, I am causing a shift to the left, because when he gets broken up, that means that the reaction is going to the left, making the other 2 guys, the reactants, the original reactants, and that's the ethene and the water. Okay, and in letter B, we are decreasing the ethene. Okay, so that's down, and of course LeChat wants it to go up, and we're going to have to do the same thing we did on the last line. We're going to have to break up the CH3CHO, and you'll notice that in both cases we're making more ethene, we're also making more water, because you can't make just one. You've got to go with both. And so that will also be a left shift. And in C, an increase in the amount of water. Oh, okay, so water's up. Now, which side of the equation is the water on? It's on the left. So, we want to get it down, and we will do that by combining ethene and water. And so the ethene and water are coming together. That causes a shift to the right. And so the ethene and the water become reactants, and the CH3CHO is becoming the product the way it would naturally be if we didn't have an equilibrium reaction. So we always refer to the guys on the left as the reactants and the guys on the right as the products. But with the reversible reactions, we have that issue that we have to consider. All right. Last thing that I'm going to do for you today is work out a couple of your homework problems because they deal with heat. And the little sheet that we got today, you want to have that out. The guy that has little boxes to tell you how to deal with concentration, pressure, and temp. And that sheet is available online on today's homework page. That is for the 25th. Okay, the 26th is when these problems are due. And these are all your homework problems. I'm actually going to do 3 of them. Okay? Is that all right with everyone? Okay, here we go. We're going to first of all look at 36A. That's in the textbook and also on the handout that I have a link for on today's homework page. And so we're looking at page 542 in Zoomdall on that page number 36A. So 36A, UO2 and HF are combining to form UF4 and H2O. Now look at the states that you have there. What state is the UFO? UF2. Huh? What state is he? Solid. Okay, he's a solid. Guess what? When we add, this question wants us to add UO2 to the system. Guess what? We can put it in. No problem there. So that's increasing it, right? And LeChat wants to take it out. No question there. However, he has a little problem. This guy is a solid. He does not affect equilibrium. And so there is no shift. Remember, solids and liquids? No effect on the equilibrium. We learned that from our equilibrium constant stuff. Okay? So that way we got LeChat in a corner. He can't do anything because it doesn't affect the equilibrium. So whether he shifts it left or right, it will not affect the equilibrium in any way, shape, or form, which is really kind of interesting when you think about it. Yes? It says it. That's what the sub S means. See, we have 3 things that we use subscripts for. One is solid, L for liquid. Both of those, no effect on the reaction. Okay? Isn't going to shift one way or the other. LeChat's dead in the water. He can't do anything. I love that. He's so naughty. Anyway, so the solid and liquid mean that they don't affect equilibrium. But if it says aqueous or gas, it will affect. Okay, and I did that in a summary that I gave you last Friday, I think. So look back at your notes for last Friday. You should see that. Or you can look in my whiteboard and you'll see it there. Okay, for last Friday. All right, letter B. Let's look at what we're doing in letter B. We got 5 moles of Xe, which is a gas, so we know that will affect something. It's being added to the system. Okay, since that's being added to the system, we know that the amount of Xe is going up. All right, and LeChat wants the Xe to go down. Now let's look in our equation, and where is Xe in the equation? No Xe. Guess what? We nailed LeChat again. Nothing he can do. Because all he can do is adjust that thing to go forward or reverse. So there's no shift. Is that cool or what? Huh? Yeah. Nailed LeChat 2 times for totally different reasons. Yeah. Actually, Xe is a gas. What's aqueous? Aqueous is a liquid, usually water, that has something dissolved in it. L is not aqueous. L is just pure water with nothing dissolved in it. Okay? So, yeah, you got to watch your subscripts. Yeah, very good. John's just pointing to it. The jug of water, though, go ahead and lift it up. That's the deionized water. Okay? If it's deionized, that means it's pure. Drink to your health. Yes, absolutely pure water. Okay. I don't know about bacteria and that kind of stuff, but it doesn't have any dissolved ions in it. And it will not conduct electricity, by the way. Okay, let's go down to 37 and see what the kicker is there. Oh, old-fashioned smelling salts. This stuff, when you put it up next to your nose, it will wake you up. If it doesn't wake you up, you're dead. This stuff is wild. So, ammonia is being made by that. Now, this is an endothermic reaction. And if you look on your little summary sheet that you got as one of your handouts today, look on the line that shows temperature. You see that? Okay. The temperature line shows you that endothermic is the reactants are on the left, or the heat is on the left. So we use heat as a reactant for this particular problem. Okay? What would the effect of the position of the equilibrium if the reaction were performed at a lower temperature? Lower the temperature. Oh, that means that heat is going down. That's the stress. It's just like, because it's endothermic, the heat being on the left, that makes heat one of the reactants on the left side. So just to let you know what's coming. So what does LeChat want to do? Because that's something he can deal with. So he wants to get the heat up. Now, we go to the side. We're going to shift to the side that produces heat. So what are we putting together to make that heat? No, if you put carbon dioxide and water together, oh yeah, carbon dioxide, water, and ammonia. All three of them. Yeah. Neville, you're on the right track. You just missed one of your products, or one of the reactants in this case. Because we as a reactant, it's shifting to the left. Okay, all those things coming together means that we're putting things together from the right side. That means we'll make the left side. If we're putting things together from the left side, we're going to make the right side. Right? Or in the case that we had up here, where is it? The breakup of the CH3CHO. The CH3CHO was on what side? Was this guy out of our... No, that's the Zumdahl problem. That's number 33. Okay. The combining NO and water. Yeah. Okay, combining the NO and water. They are on the right side. Okay? So when we combine them, the other side is coming together, or they are... Something's not right. Just a second. Do I have that wrong? Let's see. Okay, for a pressure up, when the pressure is up, we have to combine the two that are going to give us the most moles to the two that will give us the least moles. Yes, that is correct. Okay, so to get the pressure down, we had to put the NO and the H2O. That side had 10 moles, and the other side had only 9. Okay, so that's how we got our pressure down. But this was combining these, which made a left shift, because these guys are products. All right, if you look at the reaction in your little sheet, or in the textbook, it shows it in the textbook. That's where you got those. Okay, so one more. Oh, that's it. Okay, let's go ahead and go through last night's homework. And those guys were up here. So let's take those one at a time. And let's let you all react here. Just a second. Okay, we're going to the homework for the weekend that was due today, and Eric's going to be answering this for us, and he says that the pressure is up. And so, what else do you know? LeChat wants that pressure down. We know that for absolute certain. Okay, when we're talking about pressure, how do we decide where we're going to get the relief? Moles. Okay, which side has the fewer moles? Okay, the left side has fewer moles, and to make fewer moles, we're going to have to put together the side that has more moles. And what are the two things that we would put together for that? Okay, here's the reaction for 12A. We got 3 moles on the left and 2 moles on the right. Yeah? Okay, we want to make fewer moles, so what are we going to do? Are we going to put these guys together to form this guy, or are we going to pop this guy apart? Okay, we're going to combine these two, and we could put that in here instead of make fewer moles, because that will make fewer moles, because 3 becomes 2. And so we are doing what shift? We're shifting to the right. Indeed we are. Okay, very good. Let's go on. And Alan, what is our stress in 12B? Pressure is up. And how do we know the pressure is up? Because in all of these, all of number 12, the pressure will always be up because we are making the cylinders smaller. Yeah. Okay, so how do we get pressure down? Huh? Oh, he does nothing. Oh, yeah, we're over on this equation now. So this equation shows that this side has how many moles? And this side has how many moles? All right, so we got him dead. Okay, we got equal number of moles on both sides. And so no shift. Is everybody okay with that? Yeah? Understand how that works? Because if all he can do is shift left or shift right, he's helpless when they're both the same numbers, right? Okay, and we are just about out of time. I'm going to run through this just real quick. Pressure up, pressure down. Now this is for this reaction. We have 3 moles on the right and 4 on the left. So to make fewer moles, we've got to go to the side that has fewer moles, and that's the left side. And that's the way the shift will go. Yeah. When moles are on both sides are equal, like you have in this equation up here, can't do anything. LeChat's dead in the water. He cannot do anything. Okay, it was a good day. I hope this helped you all who missed today, and that you're watching this is good.